Hello everyone, welcome to my YouTube channel School of Chemistry. Today we are going to study about the nomenclature of carbon and its compound. So this chapter belongs to class 10th, and in class 10th we are mostly going to deal with the hydrocarbons. Hydrocarbons in this chapter. So hydrocarbons in class 10th is majorly divided into three categories, that is alkanes, alkenes and alkynes. Okay, so if we go about the general formula of this compound, it would be CnH2n plus 2. Alkenes would be CnH2n and alkynes will be CnH2n minus 2. Okay, these are the general formula. While writing down the IUPAC name, we need to take care of three things. Okay, in the IUPAC name of these compound, we'll be having three things. First is the prefix plus word root, and the third thing is the suffix. Okay, now prefix are the mostly substituent which come into the IUPAC name of any compound. First thing we need to focus over here is the word root. Word root is actually the number of carbon atoms, present in an organic compound. Suffix tells us about the nature of bonding, and the various functional groups which are present. Suppose we have carbon-carbon single bond, it's an alkane. So suffix we will be writing over there as a ane, A-N-E. If we have a double bond in the chain, then we have to use the suffix as the ene. If we have a triple bond in our chain, we have to use the suffix as Y-N-E. Now what is this prefix? Prefixes are the substituents which are present on the parent chain. Or we can take them as the side branches, small side branches which are present on any parent chain. Now if we have number of carbon atom as 1, that is C1, we have to write meth. If we have 2 carbon atom in the parent chain, we would be writing eth. If we have 3 carbon atom, we will be writing prop. If we have 4 carbon atom, we will be writing but. If we have 5 carbon atom, we will be writing pent. For 6, we will be writing hex. For 7, we will be writing hapt. For 8, oct. For 9, non. And for 10, it's dec. Okay, so these are the number of carbon atoms which are present in the parent chain, which we call as the word root. Okay, suffix, single bonding, and prefix is the substituent. So let us start first with the alkanes. So in alkanes, the first carbon that starts with the one carbon atom is CH4. As it has only one carbon atom, we will write its IUPAC name as meth, and the bonding is of single bonding, so we'll write ane after as a suffix. So the name of the compound becomes methane. If we have two carbon atoms which are linked to each other with a single bond, we can write them as ethane. If we have 3 carbon atoms linked to each other with single bonds, we have to write propane. Similarly, if we have 4 carbon atoms, CH3, CH2, CH2 and CH3, then we will be writing butane. Make sure that in each carbon atom the valency of carbon is satisfied, that is it would be forming 4 covalent bonds either with the other carbon atom or with the hydrogen atom. Suppose if we have the compound like this, CH3, CH, and we have a side branch CH3 and over here one more CH3. Then how to write down the IUPAC name of such a compound? So in such case, we have to first select the longest chain. After that, we have to give the numbering 1, 2, 3. The numbering should be given in such a way that the substance which are present on the parent chain will get the lowest number. So it will be getting number 2 from both the sides when we start the numbering from either left hand side or start the numbering from the right hand side. So the substance is present on the second carbon atom. So first we need to write down the position. That is, it is present on the second carbon. Now what's the substance? It contains 1 carbon. We'll write meth, METH, meth. Then as it's a substance, we have to add YL along with it. It becomes methyl. Then the word root of the parent chain. It contains 3 carbon atom. We'll write prop and the bonding between them is a single bonding. We'll write ane. So the complete name of the compound becomes 2-methyl propane. Similarly, if we have a compound like this, CH3, CH2, CH, and we have a methyl group and CH3. So in this case, we have to first select the longest chain. Selected the longest chain. After selecting the longest chain, we have to again start the numbering 1, 2, 3 and 4. Again, this methyl group is present on the second carbon atom. We start the numbering from the right hand side, and it will be on the third carbon atom if we start the numbering from the left hand side. So we have to start the numbering from the right hand side, whatever the side from where the substance get the lowest number. So the name of the compound can be written as 2-methyl butane. If we have one more example like this, CH3C, if we have suppose 2 substituents present on a single carbon atom, so again we need to select the longest chain. In this case also we will be taking straight chain as the parent chain. Put the numbering 1, 2 and 3. Now both the substances are present on the second carbon atom. So in this case, first we need to mention the position. That is, first is present at the second is present on the second, as the substance are the same. So we can club them together and write down the name with together. So it's di represents the 2 substances are there, dimethyl, then the parent chain prop, and bonding is single bonding, we write ane. So name of this compound becomes 2,2 dimethyl propane. Okay, now the question arises that what will happen if the different substituents, or you can say same substance, are present on the different carbon atom. Let us take one more example of that. Suppose this is the case we will be taking. We have to again select the longest chain. So this is the longest chain we will be taking. Okay, and in this we need to start the numbering 1, 2, 3 and 4. Now 2 substances are present. One is present at the second carbon and the next is present at the third carbon. First we will mention their position, that is 2, 3. Then dimethyl, we have the same substance at second and third carbon, we will write dimethyl. Then the word root but, bonding single, we write ane. So the name becomes 2, 3 dimethyl butane. Now the question arises that what will we write if we have different substituent on the same carbon. So for that, let us take this last example for alkanes. That is, we have a compound like this. Again, we need to select the longest chain. So this is the longest chain. After selecting the longest chain, we have to put the numbering 1, 2, 3, 4, 5, and the substituent one is the methyl and the other substituent is ethyl. So we have to write down the name of the substituent in the alphabetical order as they are present on the same carbon. So we will mention the position before writing down the substituent. So first we'll start with 3 ethyl, then we'll write 3 methyl, then is the parent chain, that's a 5 carbon pent, and then is a single bonding suffix ane. So the name of the compound becomes 3-ethyl 3-methyl pentane. So that's all about the nomenclature of alkanes in class 10th. But in class 11 we will study furthermore you can say compounds with the complex, that is getting into the nomenclature of alkanes. So let us take a look at the alkenes. Alkenes having multiple bonds. So the first compound of alkene start with the 2 carbon atom, that is CH2 double bond CH2, and the name of this compound can be written as eth for the 2 carbon atom and ene, ethene, for the double bond present between them. If we have the 3 carbon chain, then we can write the name as a propene. If we have 4 carbon atom and the first carbon is bearing the multiple bond, that is a double bond, we can write it as butene, or we can also write it as but1ene in order to mention the position of the multiple bond. Suppose we have a compound with a multiple bond between second and third carbon of the butane, then we have to write it as but2ene in order to mention the position of the multiple bond, that the multiple bond is present between second and third carbon atom. Similarly, if we have some substituents which are present over here, suppose if we attach one more CH3 and a multiple bond over here, then we'll start the numbering in such a way that our substituent and the multiple bond get the lowest number. So this is present at the second carbon, so the name of this compound can be written as 2-methyl but2ene, 2-methyl but2ene. If we have one more example like this, CH3 CH, we have a substituent over here. So in certain cases we have methyl and the multiple bond. Okay, so the student asked that sir, whether we have to cite the numbering from the right hand side, from the left hand side. So according to IUPAC, we have to start the numbering from the left hand side, that is more preferences given to the multiple bond rather than a substituent. So we'll write it as 4-methyl pent 2ene. It becomes 4-methyl pent 2ene. So hope it will help you in the nomenclature of alkenes for class 10th. Okay, and the next comes the alkyne, having the general formula CnH2n minus 2. So again, the first compound of alkyne starts with a triple bond, and that could be possible between the carbon atom only. So it also starts with a 2 carbon atom, and the first compound is named as ethyne. CH triple bond CH. So it can be written as ethyne. Next compound with the 3 carbon atom, we can write it as CH3C triple bond CH. It is propyne. Similarly, we have CH3, CH2, C triple bond CH. This can be written as butene or but1ine. As in the case of the alkenes, when the position of the double bond was not at the first carbon and start with a different carbon atom. Similarly, in the alkynes, if the multiple bond is not present on the first carbon, we need to mention the position of the multiple bond. Like in this example, we'll write but2ine as the multiple bond starts from the second carbon atom. Okay. So if we have the compound like this, then we have to start the numbering from here. 1, 2, 3 and 4. We can write 3, 3 dimethyl but1ine. So this will be the IUPAC name of this compound. Hope this video helps you in writing down the IUPAC names of the hydrocarbons for class 10, that is alkenes, alkenes and alkynes, and we'll discuss about the functional groups in the coming video. Thank you.